Good afternoon, everybody. It's my privilege to introduce you today, Olivier Grisel, machine learning expert, one of the core contributors to scikit-learn. He has a wonderful talk planned for you today about building and testing wheel packages across operating systems. So thank you all very much for coming out, and thank you, Olivier.
So hi, everyone. So today I'm gonna talk about something new. At least for me, I never talked about this before, about platform-specific build and test issues in Python. So at that point, you might ask, why me? Why did I ever deserve to do this, to be in this room? I don't know for you what are your personal reasons who brought you here, but I will tell you my little story and see how it goes. So. I'm Olivier. I'm one of the maintainers of the scikit-learn machine learning library. And I work at INRIA, so it's a research institute in France. And I work as a software engineer here, to maintain scikit-learn and to make it work better for the research scientists in that team. As part of this, we have to make releases, and scikit-learn has a bunch of compiled extensions. So releasing this kind of software in Python is slightly harder than regular Python. So for instance, this is a small zoom-out view of the last release of scikit-learn 016. You cannot see because it's too small because of the file names, but we have to generate binary packages for a different version of Python, for different version of Windows and OSX, for 32-bit and 64-bit. So that's a combinatorial explosion of packages. And so when I first did a release for that, we did it manually. We used a bunch of virtual machines. And it's very error-prone, and so we made mistakes, and it was pretty much very boring. So we decided to ask the robots to help us with this, as we do for when we do machine learning in general or software. So the outline of this talk is first, I will give a short introduction to the wheel format. It's the new recommended way to ship Python packages. And then I will talk a bit about how to test those packages using Travis CI, and we will see that it's possible to test under the Linux platform and the OSX platform, Mac OS X platform, using Travis. Then I will discuss about something that I think not many people know, is how to build Windows packages and how to test them using a similar service called AppVeyor. And once we have this, we are in the position to automate pretty much all of the release process. And so I will introduce some glue code to achieve that. And finally, if we have time, we can discuss a bit about compiler issues on Windows and how to deal with external libraries that can be shared libraries, for instance. So first, a short introduction on the wheel format. So you might have heard about Python wheels. And here you see a website, the homepage of a website called pythonwheels.com that shows that almost nearly half of the top 360 Python projects have already started to publish wheel packages on PyPI. So it's interesting because it's picking up steam, but what is it? So it's a new standard distribution format for Python packages. It's documented, there is a specification rather than just an implementation as a PEP. So it's a 4.2.7 that was validated some time ago, I guess. And it's interesting because it should be implementation neutral. So that it means that you can write tools to generate wheel packages or to install wheel packages yourself if you want. But you can also use standard tools like pip to do that, but you're not forced to use pip if you don't want to use pip. You can write your own tools because it's documented. The way it's designed is just a zip archive with the Python files that you want to unzip in the side packages of the target platform, plus a bunch of static metadata like version numbers, the list of files to uninstall if you want to uninstall the package later. You can also include compiled extensions for the target platform that you want to support, so that it's not necessary to have a compiler to install a package. You can just unzip it, and sometimes you want to also to spread scripts to the bin folder or the scripts folder on the Windows, and additional data somewhere else if you want. But the core of the zip archive is just a zip file. To generate those, right now you can use a setup py script if you install the wheel package, and you can also use pip to generate packages for wheel packages for any source distribution. Why would people want to use wheel packages? For instance, if you have a pure Python package, it's still interesting as compared to a source distribution, because wheels are generally smaller packages, so they are faster to download and faster to install, even for pure Python packages, because they don't necessarily include stuff like documentation or tests if you don't want to have the test part of the library. So they can be smaller and faster to install. And furthermore, they also provide the ability to ship precompiled binaries, which can be very useful for users who don't know how to install a compiler and header files and so on. So just to give you a feeling of how it feels to use pip wheels using pip on a laptop, a Mac laptop as of now. I don't know if you had the experience to try and install scikit-learn in the past from source, but you need gfortran, you need GCC, you need to compile SciPy as a dependency that has Fortran source code, C++ source code, and it takes like ages to build from source. If you use pip install numpy, SciPy, and scikit-learn, it takes less than 10 seconds, and it actually works. It's the last version of those guys. But even if you don't have compiled extensions, for instance, if you take a project like Nose, it might be interesting to generate wheel packages, because the wheel archives are smaller than the original source distribution, so they are twice as small in that case. So they are faster to download, but they are also much faster to install, because when you install from the source distribution, basically pip will run the setup py script inside. And in the case of Nose, I don't know exactly why, I haven't looked, but it takes 8 seconds, whereas if you install from the wheel archive, it's just 500 milliseconds, because it's just an unzip of a small archive. You can have a look at the wheel itself. You can unzip it yourself, and you will see that basically what it does, it unzips the Nose folder with the package, the Python package, inside the side packages folder of your Python distribution, and also an additional folder which is called the distinfo folder that has metadata. Especially you are expected to find the wheel metadata and record text files that have a bunch of metadata that can be useful for packaging tools. And furthermore, you see also a data folder that has a subfolder called data itself. In that case, they use that to package the man pages of the nose command, the nose test command. But you could also use that to ship scripts and additional stuff. So basically, an installer, what it does to install, it does unzip in the side packages, and then it moves the subfolders of the data subfolder into the right location that depends on the target platform. It could be USR bin for scripts under Linux, for instance, or the scripts folder of Python under Windows, and so on. So to build a wheel when you have a pure Python library, and if your source code is compatible with both Python 2 and Python 3, it's really easy to generate a single wheel that will work on all the platforms. And they are called universal wheels. To do that, you just need to edit your setup CFG file in your source folder, or the project source folder. And you add this barest wheel universal equals 1 couple of lines. And then you can install the wheel package itself using pip, for instance. There is an additional tool that we installed, which is called Twine, we'll use later. But right now, we can just generate the wheel using Python setup py barest wheel. And it will generate a single file that works on all the platform. And to make it available, to release it to, when you do a release of your software, you can generate the source distribution. It's always useful for downstream packages like Linux distribution. But you can also generate the wheel package and upload the two of them to PyPI or to warehouse in the future using the Twine command. It's better to use Twine as a side note than just the setup py upload additional command, because Twine does not send your password as clear text over the network. So that's a little detail, but it might be important. So use Twine instead of upload. So how to automate testing? First, we'll start with Linux and Mac OS X, because that's the easier or most deployed testing environment as of now. So for instance, for scikit-learn, we use Travis CI. So this is the main page when you're logged in. You see the last project that was built in your GitHub, link to your GitHub repository, GitHub account. And so you see for each pull request and each push to a pull request, you see a bunch of workers, jobs, that will run the test for your package, and you can configure it to run different runtime environments. For instance, here I'm testing with Python 2, Python 2.7, 2.6, and 3.4. Some of them is using the Ubuntu environment, the Ubuntu system packages for the dependencies. Others are using the Anaconda distribution. So that we want to make sure that scikit-learn works as the test works for all those environments. Sorry for the, the screen. So it's just a screenshot of Travis CI. If you click on one of the job, here it's green, so everything went well. But sometimes it's red if you have a failing test. And so you can see the log of the execution and see the error message and try to replicate it locally with the same environment to try and debug it or fix the issues if you can spot the error from the stack trace, the traceback alone. So how to set up a project to run on Travis? It's pretty easy if you just want to use the default Linux environment. So Travis has a native support for the Python programming language. So you just have to put this travis.travis.yaml file in your source folder, register your GitHub repository to Travis, and it will Travis will each time you do a push in a pull request, it will introspect that configuration file and spawn as many workers as you describe Python environment here. So here I've configured 2.6, 2.7, 3.3, 3.4, and Python nightly. So you have an install step where you can build the project, you can install dependencies. So in that case, I will just run pip install dot in the source folder. And then you can run the test. So here I want to run the test on my package at the end of the installation process. So I really want to run the test of the installed package. So this can only work if your Python project embed the test suite inside the library itself, which is what we do for scikit-learn. And I think it's quite useful because you can make sure that you don't have any issue in the packaging process itself, because you can run the result of the installation and not just the source code of the development folder. So here I just move to a temporary folder to be outside of the source directory and use nose to run the test. Nose is installed by default in the Python environment on Travis. What you might not know is that it's also possible to run OSX test by using, for instance, the language equals Objective-C at the header, and it will run on an OSX machine. But in that case, you don't have the Python environment because you declared your project as an Objective-C project. So you can use this Terrify tool that will install a Python environment from python.org, so that you're sure that the wheel that you generate in that environment will work on the real distribution of Python. But you can also use these Terrify scripts to install Homebrew and MacPorts Python distribution to also run the test on those environments. So if you use this trick of the Objective-C language, your GitHub repository will not be able to run the test on Linux. So if you want to run both Linux and OSX in the same GitHub repository, it's also possible to use the multi-OS support of Travis, and then to adapt your script by introspecting the Travis OS name environment variable to either use the regular Python stuff from Linux or to install a Python environment using Terrify. So here is the URL of the Terrify utilities. So we can do the same with Windows. But to do that, we cannot do it on Travis nowadays. I don't know if it's planned or not in the future. But in the meantime, you can use another service which is very similar, which is called AppVeyor, appveyor.com. So this is the home page. You can log in with your GitHub account. And you can register your project. So here, this is scikit-learn, and you can see that we are testing Python 2 and Python 2.7 and Python 3.4 for both 32-bit and 64-bit Python. And in our case, this is very important because we have numerical stability issues that are different depending on the platform. So this is very useful, and we could find a lot of bugs thanks to this ability. So if you click on one of the builds, you also have it's very similar to Travis. You can see the full log of what happened. And the configuration is very similar. It's not exactly the same syntax, but you also have a YAML file where you can declare environment. So here, this is an example for a pure Python project, and you just want to make sure that it runs under Windows. For instance, if you do file system manipulation, the paths are different under POSIX and Windows, so it's useful in that case to test under Windows that it works, even if you don't have compiled extensions. So I wrote a PowerShell script, which is called, in that case, install Python and pip ps1. That makes it possible to install the missing version of Python. So in your environment matrix, you declare the Python versions that you want to test and the location on the hard drive. And if there is no such folder, this installation script will install the matching version by downloading it from python.org. Then you put the Python folder and the script folder in the path. Then you can use pip to install additional stuff, like nose and wheel, for instance. And we can generate the wheel file, and we can install it with pip. And at the end, I also have a script section where I move to the temporary folder of Windows and run the test using nose test on my package. And this makes sure that the result of the installation process of the wheel into Windows will have all the tests pass. So it's very good to test that the wheel package doesn't miss anything and so on. So it's also possible to adapt that for a project with compiled extensions. It's actually slightly more complicated because compiling with MSVC, the Visual C compiler from Microsoft, requires you to have an environment variable in a CMD environment, in CMD console. And to launch that console, you need specific options to launch it. So this first line here, with the run with compiler CMD file, is very tricky. So it took me 2 weeks to get right of suffering. But now it's done, and you don't have to do it anymore. But once you have this, you can declare your environment. So here you can have as many Python versions as you want, different architectures. And you also run the install ps1 script. And it will download the Python and pip if they are missing. And then the only line that changes is the compiler env python setup py bedist wheel. You need to prefix it with this environment, and that will work. So to set up your own AppVeyor configuration, you had an example, but if you want to know the details, you can go to the official packaging documentation from python.org. This is a very good reference. There is a section on using AppVeyor, and they basically reused the scripts that I developed and documented it there. So originally, I had put that as a sample Python project on my GitHub repo, so Python AppVeyor demo. And then it was included in the official documentation. But yesterday, I got an happy user who sent me this. So now I have rainbow ponies because I did that. So that's great. So now that we can build wheel packages for OSX and Windows using Travis and AppVeyor, what would be nice is to reuse those built artifacts and upload them directly to PyPI or warehouse. So here is a schema of what we want to do. So we have the Travis workers and the AppVeyor workers who monitor constantly the GitHub repository. And whenever there is a new tag pushed there, they can build the matching wheel. And what we want to do is for this process to upload to a temporary wheel container store, like an HTTP website. And to do that, we can use one of the cloud providers. For instance, here we use Rackspace because they were kind enough to give us a free account. But you could use S3 and Azure storage or whatever, and accumulate the wheels there. And then when you want to do the release, you control from your laptop, you fetch the wheels that were built by the continuous integration servers for the matching version, for the matching tag that you are interested in, and upload all of them along with the source distribution to PyPI or warehouse in the future. So to do that, I wrote a bunch of utilities called Wheelhouse Uploader. And so basically what it does, it makes it possible to do the upload between the continuous integration workers, servers, up to the cloud containers using that command at the bottom. So you need to define the environment variable with your secret credentials. Both for AppVeyor and for Travis CI, it's possible to host secret values using your account. So I let you read the documentation to see the details, but you don't need to check in the password in your source code. And then they will upload continuously to your cloud container. You can monitor that it's happening. So this is the HTML view of one of those containers, where you see scikit-learn wheels for Windows. And so at release time on your laptop, you can git check out the tag of the release you're interested in, and call this command. So you need the Wheelhouse Uploader utility that will fetch the artifacts that match the metadata of your setup py file at that point. And you can configure the location of the wheels of the archives, the temporary archives, in your setup CFG file. So once you have fetched the wheels, you can test them locally if you want, if you don't trust the CI. And then you can upload the final distribution to PyPI using the twine command as you would have done for a regular project. And the result is the release. So this was actually released using that process in a single step. So I don't know if I should go to, yeah, I will speak a bit about the Windows compilers and then keep some time for questions. So under Windows, there is no compiler by default, and it's not that easy to get there, to get them installed. So the first option is don't try to install them and just use the AppVeyor integration servers, because they are already installed there, so you don't necessarily need to install them locally. But sometimes it's useful to have them locally to be able to debug on a specific branch Windows-specific issues. So if you want to do that with the free tools, it's possible, but you have to install a MSVC Express 2008 or 2010, depending on the Python version. And also, if you want to have the 64-bit platform, you also need to download the Windows SDK. And this is very big, and you cannot script the installation of those two guys because there are graphical windows where you need to accept the license, and there is no way to to script this installation process. So it's really painful and it's slow to download. I documented the whole process in the scikit-learn documentation, but really I wouldn't advise to do it anymore. So one solution for Python 2.7 is instead to use something that Steve Dower from Microsoft released last year, which is called Microsoft Visual C++ Compiler for Python 2.7. It's an old version of the Microsoft compiler, specifically released for that. There is no guarantee, but it's very useful if you want to maintain old Python project on this old Python version. It ships as a small MSI file that you can download from a fixed URL, so you can have a script that download it and install it. It supports both Python 32-bit and 64-bit. But it only has C and C++ compilers. So there is no Fortran compiler. So for instance, for a project like SciPy, it's not enough. But for most other projects, it's good. And furthermore, it doesn't support Python 3.3 and 3.4. But on the plus side, in the future, Python 3.5 will probably be built using MSVC 2015. And will be forward compatible with the next releases of the compiler, so that this situation of using an old compiler is just a temporary situation, hopefully. There is an alternative to the MSVC compiler, is using MingWinPy, which is an adaptation of the MingWin compiler specifically adapted for Python. For Python project, for building Python extensions. So what it does is that it has a statically compiled toolchain, because otherwise it wouldn't work. And it also links the MSVC runtime so that the binary that it generates are compatible with the Python that was built with MSVC. Furthermore, it provides both a C compiler and a Fortran compiler, so it should be possible to have the full SciPy stack built with that guy for 32-bit and 64-bit. So it's still an experimental project, but there is a Python distribution for Windows which is called WinPython that is already using it, and it seems to work. So I think it's a promising avenue. So if you're interested in that project, you can monitor github/mingwinpy. It was created this morning, this repo, so it's empty. But we are transitioning from the Bitbucket repo. Carl Klempner is going to move the source code and scripts and stuff to that new organization so that we can collaborate there to get this working. I think I will stop here. If you have questions, I can also speak a bit about external libraries, but I will skip now and just accept some questions. Thank you very much.
All right, folks, we have microphones here and here. We got about 3-4 minutes worth of questions.
So building wheels on Linux, really the only thing you care about is the architecture and that your libraries, for binary compiling, and all the libraries are installed and it works anywhere with that Linux and that architecture?
Yeah, so I skipped that topic because as of now there is no good way to do it because the wheel specification has not defined a platform tag for Linux distributions. Because if you build something on a specific Linux, for instance, version of Debian, there is no guarantee that it will work on Red Hat, for instance, because the libc might differ, and there is no common ground agreement or specification of the binary compatibility of libraries across Linux distributions. So there is some discussion to set up a platform tag that might be specific to either a single distribution or a group of distributions that are meant to be compatible with one another. But it's still an open issue. So if you're interested in that, I think there will be sprint discussions during the sprint discussion on that topic at the PyPA packaging authority group, basically.
In the meantime, though, you can build them.
Yeah, in the meantime, it works if you don't publish them and
right.
you're sure that you're going to use them on the same host. Yeah, then you can do it, and you can have a mirror of PyPI, for instance, where you push your own stuff for your own environment, where you control. But you need to make sure that you're not going to push two different wheels from two different environments to the same mirror, because the file name will clash, and you can corrupt your archive this way.
Okay, thanks.
You said that wheels are having advantages in size and installation speed over just like downloading the source and installing
Yeah.
setup to Pi. How
Yeah.
does it compare against egg packages?
It's very similar, I would say. The problem with X is that there is no specification. It depends on the implementation of setup tools. So this is why it's problematic, basically.
Thank you, everyone, for coming out. Thank you, Olivier. I'll be around for some questions up here if you have any.
Yeah. Thank you very much.